Hello, AP Physics 2. This is a recap of the Zoom call we had on September 30th, 2020, which was week 5. I hope this will be helpful because that call was obviously disrupted by my audio dropping out. So this will be a chance to kind of go through the problems a little more detail and just kind of make sure everybody's on the same page about them. The coming unit, thermodynamics, is going to be about conservation of energy at its heart. And we're really going to look at 2 ways you can add energy to a system, namely by doing work on it. You've had a little experience with that, but also by adding heat to it. Today, we're not going to worry about heat. That's a new topic for you guys. But I do want to review a little bit of what you've learned in a prior physics class. So let's take a look at the problems I had folks doing. So I think these are increasing levels of difficulty. The key thing about this one here is you're doing work on it and it's moving to a different location. So its potential energy is changing, and between the potential energy and the work you're doing, it sounds like kinetic energy is probably going to get involved too. So following the energy original equals energy final process, you end up with something like this. So I have the original potential energy and the work done by U is equal to the final kinetic energy. So there's my equation for potential, and here's work done by U. The reason it's an X is the AP equation sheet usually says that work is Fx cosine theta. Plug in stuff and I get 4.54 meters per second. So that one I hope is a little bit straightforward. Why is it a positive work? It's a positive work because it's adding energy to the system. And based on the conventions I use for this to keep track of where to put the work terms, I always put them on the EO side. And if it adds energy to the system, it's positive work. If it takes energy out, it's negative work. Next 2 questions are more challenging. You definitely probably want to try them before you watch much farther or look at the answer key. But the key thing here is you are pushing, so you're going to be doing some work. But there's also friction. Friction's a non-conservative force, so the work it does is going to take energy out of the system. So the answer to this looks kind of like a hot mess at first. But the key to it here is this. EO equals EF. This didn't have any potential energy at the beginning. It's a desk on the floor. It does end with kinetic energy. And how much kinetic energy it gets is going to be the difference in how much energy I put in and how much energy friction takes out. So what I then need is I need how much the size of my force is and how much the size of friction is. So fairly easy to get the size of my force, although it's important to remember that not both components of my force do work. If this is my force, the X component does work because it's in the direction of motion, but the Y component does not. That's what the cosine 35 is there to correct. Now, as for the work done by friction, we have to calculate the force of friction. And that involved doing a sigma Fx and sigma Fy equation. First to find the normal force, and then use that to calculate the frictional force. So I end up with a final speed of 1.34 meters per second. Try to make sure you understand that second problem pretty well. And you're going to probably have to spend some time with the answer key before you start the third one. But the third one basically has exactly the same type of strategy. Notice it's asking how fast will it go after 3 meters. So probably what you're going to do is find an acceleration and then use kinematics equations to get a final answer for that. So this is what its answer key looks like. And I'll not spend too much time there so that it can be a surprise for you. Good luck on this. I really think you guys are all doing a good job under hard circumstances, and just reach out if you need help. Be in touch. If this was a normal year, we'd be spending a lot of time working through these problems together. If you have the opportunity to work with somebody else, please do so. And if you ever feel like you need someone, get in touch with me. Thank you.